Hi, this is Ben Welsh again here in the LA Times newsroom. And in this video, we're going to pick up right where we left off and begin interrogating the database that we've developed and start doing the journalism that we all set out to do when we started this class. All right? So where we left off, we had taken the complete list of all the committees from the November 2016 ballot measures, all 100 and some, and we'd filtered it down to just the Prop 64 marijuana committees. And then we had used that list to do a merge with the complete contribution set to filter that down to only contributions for and against Prop 64. And in that sense, we had taken our raw data, we had imported it, and then we had prepared it for analysis. And this process of taking the raw stuff that you get and winnowing it down to the stuff that you actually want to analyze is a part of every piece of data journalism. And even though the California Civic Data Coalition's mission is to make that easier for you, it's still going to be part of the process no matter what you do. Because before you can begin asking specific questions, you have to set up the data so that you're asking the right stuff. All right? And I think we've pretty much done that. We've now arrived at a new data frame, which we call merged, as you may recall. And if you don't have your notebook up, you need to do that. You'll need to activate your virtual environment, fire up your notebook, and get down to the bottom where, when we last left off, we joined together the prop and contribs tables to create a merged data frame for analysis. So this list is now really all of our marijuana contributions, and we can begin asking very specific questions about that prop and who was for it and who was against it to this variable, to this data frame. So let's just start with something really simple. All right? My first question, hey, what's the total amount of money that was raised in this race? Both for and against, the whole pot, how much was there, right? Well, how could we get at that if you think about it? Well, as you probably remember, there's a column in the contribs table. Oops, I'm losing myself in the scroll here. There's a column in the contribs table called amount. And that column includes the amount that was given in each of those records as reported by the committee when they received it. And we can see here, even in this row, there's some pretty big amounts in here. If I'm reading that right, that's $250,000 that was given on one check on one occasion. And we've got several hundred more contributions like that. How much do they all add up to? Well, since it's in that column called amount, we can really quickly find out using the tools built into Pandas. And this is where things really start to get fun. So we've got our merged variable, which I've set right there. And then yet again, I'm going to hit the period, which is going to open up all the different columns and methods that Pandas has built in there for me. And since I want to look at the amount column, I'm then going to type that, right? And then I can chain another period. And now after this, I can reintroduce all of the basic statistical methods that we started off with way back in the beginning when we first tried out Pandas. You guys remember those, right? Like average and median and min and max. All those different mathematical methods are available for us to use on the amount column because it's a numerical float column that has decimals in it that can be analyzed in that way. And so my simple question was, what's the total amount of money? All right, that can be achieved by putting in the sum method. So merged.amount.sum, and because sum is a method, it has to be executed or called with an open and closed parenthesis, and then simply hit play. And just like that, we calculated the total from that column. Now, Pandas doesn't print things out very pretty, which is another slight downside. There are ways to fix this if you Google it and look into it. We won't cover it in this class. But by default, it just prints out the numbers without any formatting. And if I'm reading this right, it looks like that there are $35 million worth of contributions, both for and against Proposition 64, that showed up in this sheet. Now, wow, that sounds like news, right? Hey, if this was maybe last fall, right before the election, or if you're looking to do some retrospective piece about what happened in the election, you might think, I've got the number I need. I can take this $35 million figure and I can write it into the nut graph of my story or tweet it out today or start to use it in charts and graphs. In most cases, that definitely is true, but the reason I'm throwing up this total is it's actually not in this case. And now I would like to take a short side trip into the nuances of analyzing campaign finance data that is definitely very, very important for anyone who wants to get started in doing it. This is actually not the total amount of money raised in this race. It's a little less. And here's why. In the state of California, the names and identities of donors only have to be disclosed to the public when they give more than $100 in a calendar year. So if you give $101 or $100.01 to either of these campaigns, your name will show up in the public record and in our data and probably on the internet somewhere, right? Now, pardon me, excuse me, I made it this far in the class without sneezing, but I knew the time would come, and so let me just wipe my nose briefly, and I'll pick up where I left off. I'm sorry. All right. Now, as I was saying, unless you give $100 or more, your name is not going to show up in this registration or in this data that we download. If you give less than $100, your identity in California is effectively concealed, and you don't show up on our data. And this is not just true in California, it's true all across the country. The limits differ on where the cutoff is, where a name has to be disclosed, but they do exist, these cutoffs, in almost every other state and also at the federal level. So if you give money to a presidential race, if you give less than the cutoff, your identity is not disclosed. If you give more, it is. And so the result is that any totals that you draw from the list of disclosed donors is actually a fraction, usually a very large fraction, but is only a fraction of the overall money raised because it does not include those smaller donors. And the technical term for them is an unitemized contribution because they're not broken out. And so to calculate the overall amount of money raised by a campaign, you actually cannot use the individual donor list. Instead, you have to look at the cover sheets that are included on the front of disclosure reports and also in our databases by those campaigns, which include those unitemized contributions as a lump sum. And by adding those to the disclosed lists, you get the overall grand total. The accounting can get a little more complicated in cases of loans and transfers between related committees and some other issues, but the really basic thing you need to know is that a list of campaign donors is almost always not 100% of the money that campaign has raised. And this is a bugaboo that many rookie data journalists sort of overlook to make mistakes and to underreport or misreport the amount of money that's being raised. Now, while it is a limitation, it is not a deal breaker, okay? The data that we collect in these lists, the donors who give more than the cutoff, are almost always the large majority of the money that's given to campaigns, and they include such rich data about the donors' identities that they're really worth working with, right? And there's not much alternative. There's nothing else out there. And so this caveat, or this kind of sort of trick, is the reason why, if you were to read carefully an analysis of campaign finance data in the LA Times where I work, or in other major media outlets around the country, you would often see that they refer to their analysis as being limited to so-called large donors. And that's a small piece of, I guess you would call it, tradecraft that's used by people in our field to sort of signal that this analysis is based on a donor list, but also to try to indicate that it isn't all donors or 100% of the donors. It's strictly those that are available, which is almost always based on the amount they give. Now, of course, there's always caveats to things like this too. Maybe a campaign chooses to voluntarily disclose their smaller donors, or they accidentally do so, or who knows, right? So these rules are not always true in 100% of cases, but this is a big one that you need to know. So the total that we actually calculated there at $35 million is not the total amount raised for Prop 64. It's the total amount raised from so-called large donors who gave more than $100. I've calculated the overall total elsewhere as part of some stories at the LA Times, and it is a little bit higher than $35 million due to those small donors, but not a whole lot. And so as we proceed from here on, we need to keep in mind this caveat when describing our totals so that we don't get things wrong, all right? And being very careful about how you word your analysis and how you arrived at your totals is very important when doing this stuff. And you should, especially if you're new, be always checking how you do things against the official documentation and maybe even vetting your results with experts in the field outside of your newsroom. All right, my little speech is over. Let's get back to coding. Okay, so now we have that overall total. I am kind of curious to know, though, hey, which side raised more money? It won't be overall how much money, but which side raised more money from the large donors who are most of the money? Did the support side raise more, or did the opposed side raise more? And we can calculate those totals using a very similar trick to the one above by summing the amount column. But first, we need to filter the merged table so that it has either only the support contributions or only the opposed contributions. And we can do that using the filtering tricks that we learned in the previous videos. And so if we look here at the columns on our merge table, there's one that's called committee position. And that column indicates whether that individual record is a contribution that went to a committee that supported the measure or a committee that opposed the measure. And we can use the values that are in that to filter down our set to create two separate data frames, a support data frame and an opposed data frame, and then we'll calculate the totals of each, right? So first off, we need to know what to filter by if we're going to create an expression to filter down our table, and we don't know right now, hey, what exactly is in that column, committee position? Well, a really easy way to inspect, hey, what's in your column is a trick that we already learned, value counts, right? So if we do merged dot, then the name of the column, committee, two T's, two E's, committee position. And again, I can use that fun tab trick to fill it out. You see how I did that, guys? I just did committee underscore and then the first couple letters and then tab, and the notebook went in and typed it all in for me so I couldn't make a typo. It's a great shortcut. It's maybe my favorite shortcut. So then I type that merge dot committee underscore position dot, and then again the name of that method, value counts, open parenthesis, close parenthesis, because it's a method. And then I hit the play button, and look, it's returned for me a group and count on that column for the whole data set. And you can see here that the support value, which is support all caps, has 762 records, which means 762 separate large donations. And then the oppose value, which is just oppose all capital, had only 98 large donations. So we can conclude, you know, as part of our interview of the data here, that support received a higher volume of large donations, but we don't know which side received a higher amount, because it's always possible those 98 checks were really, really big. And all it takes is one big one to make a difference. So let's go back down to our next cell and let's try to filter or split up our merged data frame into two separate ones. The first one I want to call support. That's the variable name I want to give it. And as you get better at doing these filters and these techniques, you can start to write the variable before you even write the code, because you already know where you want to put it and you're confident in what you're doing. So let's try to write the code strictly left from right this time, rather than doing individual pieces one by one. So we'll do support space equal space. Now it's the merged data frame is the one I want to filter down, right? So I'm going to type in merged, because that's my data frame. And as you may remember, to do an index-based filter, you do a flat bracket after the data frame. So merged flat bracket, because that's the table that we want to filter down. Now, next, we need to write that expression, that three-part expression that's going to tell pandas how we want to filter things, right? And the first thing that expression needs is a column. So the column we want to filter on is merged dot committee position. Now it always feels weird to type the data frame's names twice, but that's what you need to do, because that's how you access the column, is merged dot committee position. That's the first thing in the expression. The second thing is the operator that we want to use to evaluate this column versus a value. And the operator we want is equal to, right? We want to check if the committee position, in this case, is equal to support, because that will be our support variable then. And so we're going to do two equal signs. All right, and now another space, and finally the third thing in every one of these expressions is the value to compare the column against. And since we did our value counts, we know that that is support all capital letters. So I need to do quotation marks, two quotations, and then between them I need to type support exactly as it appears here. And then that will result in this merged data frame being filtered to only those records where its committee position column is equal to support. Okay, and the result, that filtered down data set, will go into the support variable. So I've done that, and I'm going to hit play. And nothing happened, it just moved on. That's a good sign. Now we want to do the same thing for oppose. And so here I'm just going to copy the entire cell. Copy, paste, and I'm going to change the variable name to oppose. And the filter stuff is actually all the same, and all that needs to change is in the quote, we need to change the value to the other value, which was oppose, which we know what was oppose because that's what our value counts spit out. So I'm going to click on that and then hit play, and nothing happens. Again, a good sign. Now, if you've had errors here, it's almost certainly just because of some small typo. Make sure that the column is spelled correctly. The data frame is right. Look carefully at that error message and see what it's trying to tell you. Are you sure that you have two equal signs? Are you sure that you have quotes on both sides of these values? All those things are really picky and have to be just right. But now that we have them filtered down, we're ready to find out which side got more from large donors. And as you recall, up above, when we did our grand total, we just did the data frame, the column, and then the statistical method we wanted to do, which was sum, right? And so here I'm going to instead this time start with support dot amount dot sum, open parenthesis, close parenthesis. Then I hit play, and look out, there's the total. And if I'm reading this right, it's $32 million. That's quite a lot. Now if we do the exact same line, but we substitute in oppose dot amount dot sum, open parenthesis, close parenthesis, hit play, we get that the total for oppose was only $2.5 million. So as we probably should have suspected when we saw that support had so many more donations, we see that it also has many, many more total dollars raised from large donors. Now, these operations that return these numbers can actually be combined with each other to answer other questions. Like just to close out this lesson, one question I can imagine is, well, hey, what percentage of that large donor money went to support? It's 32 million out of 35 million. I could try to do that off the top of my head, but I'll probably screw it up. And so how can I do that automatically? Well, if you copy the line we wrote there, which again is just returning that number when it's complete, and you paste it below, support.amount.sum, open parenthesis, close parenthesis, this line of code can be combined with basic mathematical operators that are built into Python to do really anything you want. And so I want to divide that number into the overall total of large donor money to see what the percent is. And so dividing in Python is as simple as a slash mark like that. I'm putting spaces on either side. Then I'm going to go up here and I'm going to copy that other line, merged.amount.sum. You could type it if you prefer. Paste it there. And so now I'm dividing one expression into the other. They don't need to be saved into variables, though we could save them into variables. They can be called right there in line and then combined with the simple mathematical symbol. I hit the play button and we can see that 92.8% of all the large donor money that was raised for Prop 64 went supporting the measure, which was supporting the legalization of recreational marijuana, which was the side that ended up winning at the ballot box. All right, this was a lot, but hopefully not too tough, because I think you guys have built up to this pretty well. There's lots of other ways to slice and dice the data as part of your analysis, but the basic tools that you learned in this video are ones that you'll use again and again if you become a Pandas developer, and I hope you do. All right.